All right, thanks for checking out this video on quadratics, graphs, and features. I'm going to take you through what you need to know for this spiral review topic real quick. All right, so let's start it off. We start with a quadratic function, 2x squared plus 4x minus 6. We know it's quadratic because it has the x squared. All right, so how do we fill out a table? Well, a table works like all functions, input and output. So we plug in the x value into our function, so it goes 2 times negative 2 squared plus 4 times negative 2 minus 6. We do the squared first, the order of operations, so this comes out as 2 times 4 plus negative 8 minus 6 gives us 8 minus 6, which works out to negative 6. Okay, and so if we go to our graph over here, we can see when x is 2, the y value hits right here at negative 6. And so it works both ways. We can use the table to come up with our output values, or we can use the graph as well. So let's use the graph to fill in negative 1. When x is negative 1, y is down here at negative 8. So I know that this is negative 8. Same thing at 0. Plug in 0, and my output is negative 6. Now 0 is nice because if you plug it in, 0 squared is 0 times 2 is 0, and 4 times 0 is still 0, so we got 0 plus 0, take away 6 gives us negative 6. And at 1, our point is 1 comma 0, and at 2, 2 is way up here, it's off the charts. I'm not going to worry about it right now. But you should notice this symmetry. Negative 6 matches with negative 6, so if we kept going on our graph here, negative 3, all right, 0 would match with that, and so on and so forth, okay? Now, how do we describe this graph? The direction is either up like a cup or down like a frown. When you look at this, it's holding water, it's up like a cup. The vertex is the bottommost point. This is our vertex, negative 1, negative 8. The axis of symmetry is the line that goes right down the middle. It's not drawn in, but if we were to split this graph in half, it would cut it right down the middle. What happens on the left side happens on the right side. Notice this is 2 units away, so this is 2 units away. So it's right down the middle, and our axis of symmetry is x equals negative 1. Our minimum or maximum value that goes with our vertex, in this case, it is just the negative 8. We're talking about the y value, the maximum or minimum y value. And then last but not least, our x and y intercepts. X and y intercepts. X-intercept, these 2 points, it's where the graph crosses the x-axis. So we've got our x-intercepts at negative 3 and also at 1. So we can write them as an ordered pair. Negative 3, 0, and 1, 0. And our y-intercept is where it crosses the y-axis, and that is at 0, negative 6. All right, so that's the describing the graph part. Now let's take a look at what else we can do with this function. All right, something I want you to notice, these two functions are the same. Check this out. In blue and in red. Notice how they overlap. Hey, here's my red graph, here's my blue graph. They are the same function. They look very different. This is in standard form, this is in factored form. And so how do we go from standard form to factored form? Well, that's where we use our skill of factoring, right? Now, before you factor, you should notice that each of these has a common factor of 2. So my first step is factoring out that 2. That leaves me with x squared plus 2x minus 3. And then I can factor this using the diamond and the area model. So I place my a and my c value, and I use my diamond. We've got negative 3x squared and 2, so 3 and 1 with a negative 1 here. 3x, 1x. We end up with x plus 1 and x plus 3. And let me try that again, a minus 1. Put the negative here. And so here we go with our factors. Now, how does this connect to our graph? To our graph. Well, right here, x minus 1. Draw your attention to this x-intercept right here at positive 1, because what happens when x equals 1? We'll plug in 1. 1 minus 1 is 0. Okay, over here, x equals negative 3. What's special about that? Negative 3, plug in negative 3. Negative 3 plus 3 is 0. And the zero product property says anything times 0 is 0. And so that's how we find our x-intercepts. All right, so that's what you need to know for quadratics, graphs, and features. Thanks for tuning in.